Okay, this is another word problem, and it is a word problem. There's several of these like this. You could see them in the examples, especially section 6.3. You could see them in the homework problems. You can see them in the review at the end of the chapter. But the point of the word problem here is we have to combine two vectors to come up with a resultant vector. In this case, it's a plane which is flying. Its intended velocity is 580 miles per hour, and it's flying at a bearing of north 60 degrees west. Okay. It encounters a wind which has its own velocity, 60 miles per hour from the southwest, which is, they didn't say it in the problem, but southwest, you could figure, right in the middle of quadrant 3, that means the wind is coming from 225 degrees. And we want to add these two vectors up and figure out what is the wind speed and direction of the actual speed of the plane. I don't want to take up too much board space here because this is definitely going to take a little bit of space. So 580 at north 60 degrees west. North 60 degrees west is like that, right, where that's 60 degrees. And if the wind is coming from the southwest, that means it's coming from this direction. But it's probably more useful for us to draw it here. It's still coming from the same direction, 225. And its speed is 60, so it's a much smaller vector than this vector is. Right? If it's coming from 225, then what we're really interested in here is what is this angle, right? So let's see. Let me change colors here. So we could see for the plane's direction, we're going to actually be using not 60 degrees, but that should be 150 degrees. And we could see for the wind, this direction right here, if it's coming from 225, then it's actually 45 degrees. Okay, so let me call these V1 and V2 as vectors, right? V1 can be the speed of the plane. V1, change back to blue. V1, right, has a magnitude of 580, and we know that it's flying in the direction of 150 degrees. So it's going to be cosine 150, sine 150. And V2 will be the speed of the wind, and that is 60 miles per hour. That is the magnitude, and that's the cosine of 45, the sine of 45. Okay, we want to add these two. Right, when I add these two, I'm going to get this resultant vector. My pen is not quite straight. So if I add this vector plus this vector, I get this vector. So we're trying to find the magnitude, the length of that, and its direction with the positive x-axis. So how do we add vectors? We add the components. So let me simplify this. Right. V1 equals, and I'm going to go right ahead and do this on my calculator. 580 cosine of 150 is negative 502.3. And 580 sine of 150 is 290. Okay, we're adding V2, which will be 60 times the cosine of 45, 42.4, and 60 times the sine of 45, should be the same thing, 42.4. Okay. When you add those up, the sum, V1 plus V2, which is the resultant vector, should just be the sum of those components. So I'll say negative 502.3 plus 42.4, negative 459.9. And 290 plus 42.4, 332.4. Okay, so that should be some direction to the left in the X and up in the Y. It looks generally okay. How do we find the magnitude of that? Same way we found the magnitude of a vector before, right? We do the square root of negative 459.9 squared plus 332.4 squared. Square root, I'm getting 567.4. So that is the miles per hour, the length of that vector, right? How do we find the angle? Again, we do tan inverse of these coordinates here, 332.4 divided by negative 459.9. Second, tan inverse 332.4 divided by negative 459.9. I'm getting negative 35.9. Which would actually be down here in this quadrant, but we know that that's not true. We know that if we add 180 degrees, we're going to get another tangent, another angle where tangent has the same value, and that's the one we're looking for. So we add 180. 144.1.